All right, so it is, depending on which time zone you are, time to start. So thank you everyone for jumping on the call. We have quite a number of people today, so thank you all for taking time out of your day. This is Danielle Cowgill, I'm the host with ACCE, who is moderating this session entitled Discovering and Disclosing Vulnerabilities in Medical Devices. I hope everyone's doing okay and staying safe out there. I know it's kind of an unprecedented time right now. So we appreciate you guys for joining us today. Today we have two speakers from ARMIS, Curtis Simpson and Dora Zuzman, and I will let them introduce themselves and get started. But before that, if you have any questions at any time during the presentation, please feel free to type them into the Q&A or chat window. We'll save them for the end, and then I will read them to the panelists. If we run out of time, feel free to send them to the ACCE Education Chair, and we'll follow up with both panelists and you to make sure your questions get answered. And with that, I will let the presenters begin.
Excellent, thank you, and thank you for the introduction. And as was stated, thanks everyone for making the time today. So I'm Curtis Simpson, I'm CISO at ARMIS, and Dora, I'll let you introduce yourself.
Hey, so I'm Dora, I'm a security researcher at ARMIS.
And with that, we'll go ahead and get started. So thanks everyone for joining us today. Actually, before I go to that slide, I'm going to go back to you. Sorry about that. All right. So our goal today is to help bring awareness to the risks associated with the many forms of interconnected devices within the healthcare environment and how we help bring awareness to such risks, the importance of these risks, and ultimately how we help our customers manage these risks through our service. And what we're going to do is we're going to speak to a couple angles of this, both from a risk perspective, a research perspective, and a product perspective. So let's dive in. From an agenda standpoint, we'll be first looking at the threat landscape, really what types of risks and threats are healthcare practitioners facing in today's day and age. What is vulnerability disclosure, and sooner, what value does research provide in helping customers like yourselves, entities like yourselves manage risk, and really how does it help our product help customers manage risk? The vulnerability research mindset, really what causes a vulnerability research to tick, what drives them, and what value do they provide to the larger industry. We'll talk about a few use cases, or a couple of use cases that very much relate to the topic today, and we'll dive into questions. So I wanted to start first with a visualization of today's healthcare environment. In this visualization, what you're ultimately seeing is everything from traditional or more traditional IT type devices, like a laptop, or in this case, a medical laptop. You've got traditional IT devices like network infrastructure sitting behind all of this, but then of course you also have the devices, biomedical and patient care devices, such as infusion pump and MRI machines, and syringe pumps, ultrasounds, etc. Now, the reality of this visualization in today's landscape is these devices are all fundamentally connected. They're either connected directly to a network or connected to devices that are connected to a network. We're also going to spend some time today in today's session talking about the similarities and differences between all of the devices in this visualization. So there's a vast difference between an ultrasound and a laptop, but again, there's also a number of similarities that drive a lot of risks and a lot of the situations that we're seeing today and we're ultimately witnessing. As we work with our various healthcare patients, and as you very much relate to, and I'm sure very much resonates, a lot of the conversations we have with our healthcare customers are around these 6 overall risk scenarios. First and foremost, patient safety, of course. Many folks are worried about risks that we have seen and events that we have seen out in the wild, being that these devices being used to actually service patients within a healthcare facility could be compromised, are compromised. What does that mean to patient care? There's, of course, disruption of service. Many of the events that we've seen in the public have been tied to ransomware, These ransomware events have not just shut down traditional IT equipment within these facilities, but in many cases, actual equipment such as MRI machines and such like that. There are concerns about data breaches, or through any form of device within the landscape, either traditional IT devices or the devices being used to provide care. Concerns around utilization, maximizing efficiency of the devices, having an understanding of where they all are from an inventory perspective. And then one of the common conversations that we've been having more and more regularly with healthcare practitioners and service providers and such is the exposure on both sides. There's the exposure in terms of the actual devices being used to provide care, and the exposure in terms of the IT devices and how they all connect to one another. So let's take a look at what today's modern device looks like, and let's talk about some of the similarities and differences. So when you think of something like an infusion pump, a patient monitor, et cetera, we at ARMIS ultimately define these devices as unmanaged devices or unagenable devices. There's a reason why we call them that. When we look at devices in an environment, and very much in a healthcare environment, we break them into two categories, managed and unmanaged. Managed are the traditional IT devices that, to be honest, IT's managed for decades. These include laptops, mobile devices like tablets and phones. And on these traditional devices, they've got an operating system like Windows or Android or iOS on an Apple device. They've got software that allows users of those devices to do the things that they want to do, but they also have software that's used to connect these devices to networks, other devices, etc. Now, when you talk about the similarities between traditional IT device and an infusion pump, patient monitor, etc., it's pretty much where the similarities begin and end. So many of these traditional IT devices have been, again, built for decades, tweaked for decades, and enhanced over time to the point where companies like Microsoft have very rigorous processes in place to release patches every second Tuesday of every month that every company understands how to apply to their different devices, and they do so on a regular basis. It's long since been operationalized. And many of those devices come from a few different manufacturers. It's very much a short list. You only have devices coming from a few manufacturers, the software running on those devices coming from a relatively small set of manufacturers. But then you look at all of the other devices within the environment. Again, similar from the perspective of they all have an operating system, they all have software that allows them to connect to other devices and networks. But where one of the other similarities applies is the fact that how devices are compromised, so how a laptop is typically compromised, how a mobile device is typically compromised are through those things, through the operating system, through the software that allows them to connect over networks. The differences are that IT's been managing these other devices for decades and in turn has, again, operationalized processes, have built tools that can be installed into these devices like antivirus solutions and such like that are looking for attacks, responding to those attacks, preventing those attacks, etc. Now, when you look at these other devices, there's a lot of differences. And again, the list of similarities is pretty short, the list of differences is pretty long. These devices in most environments come from many different manufacturers and running numerous different operating systems, running different pieces of software. But they were really only designed for one purpose, whereas a laptop is designed for a litany of different purposes. It's being used in healthcare environments, manufacturing environments, it may be used by a graphic designer, it's being used by a college student, many, many, many different purposes. And as such, it's had to be built to be very flexible. It's been built with security in mind, as many different attacks have happened over the years at the public, et cetera. And those companies have gotten better and better and better over time. And all the folks that we're very familiar with, ranging from Microsoft to Google, et cetera, have really doubled down on investments in security. Many of the other players within the market, though, that are building these other devices, again, are building them with one purpose or a couple purposes. They're purpose-built devices that are designed to connect to a network, connect to other devices, and do the one or two things that they're intended to do. In turn, these devices are not designed or built to have other software installed on them. They're built to do the thing that they were built to do. So security practitioners, IT resources, anyone within an environment that would traditionally be installing additional software to detect and respond to attacks on these devices just doesn't work in this landscape. These devices don't allow software to be installed, And in many cases, if they do, which is very few, in these scenarios are few and far between, that software can be incredibly problematic, can actually cause these devices to fail. Devices themselves are hard to update. And unfortunately, we've seen this, and Dor will speak to some of this in today's session, where in some cases, we've actually spoken to manufacturers where they are able to patch an exposure in a device that's allowing for attacks to happen within a healthcare environment, but they don't because they're quick to realize that the process to update those devices is time-consuming, problematic, requires the devices to be physically touched, someone to do something with the device itself. So they haven't released patches in some of these cases, or if they have, in many cases, unfortunately, downstream, folks have had a hard time applying them or just haven't applied them for many of those reasons that I just mentioned. Touched on the fact that multiple manufacturers are often involved in building these devices in our landscape. Prior to ARMIS, I worked in an enterprise environment where the manufacturers building our unmanaged and unagentable devices, all of our IoT and OT devices across the landscape, that list was in the hundreds. So as you think about, even if there were patches made available, if hundreds of manufacturers were making those patches made available, there is no central means of managing those patches. A lot of those patches are going to come out from different manufacturers with different steps, different guidance, requiring someone to have to weed through all of that, and it's almost impossible. We continue to see our customers struggle through working through that and looking at alternate solutions that can manage the risk without having to worry about all those patches. And we'll talk about this a little bit more shortly, but these devices are growing exponentially every day to the point where there's billions of these devices across the world. And the percentage of these devices within almost every form of environment has grown to be very significant. And as I touched on, these devices are very vulnerable for the reasons I mentioned. So this slide is obviously not just healthcare centric, but a slide that we use to speak to many individuals around the world. And really the intent of this slide is to show the growth that I just spoke to. So those traditional devices that we've been managing for decades have really stopped growing in terms of the number of these devices deployed. And the reason for that is they're mostly a 1-to-1 or 2-to-1 type of scenario where you have, as you see on the right side there, maybe a laptop, a tablet, and a smartphone assigned to an employee. So you can basically take those 3 devices, multiply them by your number of employees, and that's probably the maximum number of those devices you have within the environment, plus or minus a few. Well, the difference between a lot of these other devices across the landscape is that these devices, again, are purposeful. We're seeing devices that are connecting to other devices just to monitor their health and to trigger alerts as to when that device may be failing. Seeing devices that are connecting non-traditional devices like OT devices in the healthcare environment, could be an MRI machine, to reporting solutions, so real-time reports can be provided more regularly to executives, to boards, etc. We're seeing a continued interconnectivity across every sector as bridging the gap between traditional IT. But ultimately, what the takeaway is from this is that the growth of those devices, while solving all of these business problems across the litany of different landscapes spanning industries and sectors, is exponentially larger than we're seeing with traditional devices, because these devices are effective in solving the problems. They are helpful in, again, helping to identify things like when a device is about to fail by looking for certain indicators and then being able to trigger that over to IT or to clinical engineers to be able to respond accordingly. They're value-add devices that are providing value, reducing costs, increasing speed, and allowing companies to continue to be competitive in the landscape. And for that reason, they are going to continue to grow. In addition to that, we're seeing a level of unmanaged devices forced upon industries and sectors. You think about things like vending machines and smart TVs, and even from my past enterprise, benign devices like safes. Everything these days is being connected to the internet and networks because those service providers see value in doing so. The vending machine example is a great example of unmanaged devices being forced upon enterprises, because a vending machine was traditionally something that sat in a cafeteria, sat in a staff area, and was manually filled with product maybe once every month or whatever that looked like. Well, now, as service providers want to cut their costs, just as every other industry and sector does, they're looking at, well, maybe we can minimize the number of visits to a customer by actually understanding when that machine is running out of chips or sandwiches or whatever else using technology. So they have. But the interesting thing is you go to any environment and what you're ultimately seeing is all of these devices being network connected, all interacting with one another in one way or another, and all ultimately creating a surface of risk. So with that, these are a few stats coming out of a recent Forrester study and corresponding findings report, where after speaking to many different customers across many different industries and sectors, these are a few takeaway metrics. There's a lot more coming out of that report. They ultimately identified the few that you see before you. 84% of security professionals believe IoT devices are more vulnerable than computers. And it's for many of the reasons that I mentioned, or the reasons that I did mention. 67% of enterprises have experienced an IoT security incident. I'll get into a little bit more on that in a second. And 74% of security professionals say that security is inadequate for IoT devices. They're saying that because most security practitioners have gone through a learning curve, which is try to use what we have to discover these various different devices, manage the risks around these devices, realize that our traditional solutions are more aimed at traditional devices, and then start looking at additional capabilities to understand and manage the risks around these devices. Many security professionals have been going through that curve over the last couple of years and coming to the conclusion that, again, those past solutions are just not effective because they solve past problems. So speaking to some of the events that have gone public, have been occurring in the wild and really growing in intensity, they range from, as it says here, even the FBI warning about smart TV security. This was issued to consumers, but quickly looked at by enterprise environments because smart TVs are everywhere, right? Every single facility has smart TV being used for some sort of business purposes, whether it's broadcasting news or television programs in a waiting area, to being used in some of the IT workspaces as teams try to collaborate together. They're everywhere, and they're being targeted by bad actors because they're everywhere. And again, going back to the fact that non-traditional solutions are most prevalent in a lot of these environments and not effective on these devices. You're also seeing stats such as there was a 300% uptick in the number of attacks against IoT devices in 2019, and that number is continuing. Gartner ultimately declared last year that we will see at least 25% of cyber attacks occurring through IoT or unmanaged devices in 2020, and we're already seeing that. This one is particularly interesting. The next one here on the slide being Microsoft warning that Russian hackers can breach secure networks, etc. This actually was disclosed by Microsoft last year, just before a large security event known as Black Hat. And again, very interesting because what Microsoft uncovered was the fact that not only were Russian hackers able to breach secure networks and attempting to breach secure networks, this was actually a nation-state arm of Russia, meaning that this was an attack group funded by Russian government to go after other targets around the world. And they were targeting 1,400 enterprises ranging from public sector to healthcare to manufacturing, you name it. They had penetrated some of those companies. They had been actively targeting and attempting to penetrate others. But this was 1,400 enterprises across all industries and sectors that they were ultimately trying to breach through very typical devices like voice over IP phones, printers, and cameras. And then the fourth is actually a story around a finding that we're going to speak to in more detail, so I won't take Doris' thunder away. So let me move on to the next slide. And just last month, we saw was an article in the Washington Post where the Department of Homeland Security and Interpol are both warning an increased attacks against hospitals around the globe. Unfortunately, what we continue to see, and we've seen this since the dawn of cyber attacks, attackers go after targets that are down or in a bad situation. Ultimately, the term that we typically, or the saying that we'll often say is attackers are kicking people when they're down. And the reason is because their attacks are more likely to be successful in a situation where someone's already facing a crisis. So you think about a ransomware event, someone's far more likely to just pay that ransom and recover from that event if it's currently curbing their ability to respond to the current world crisis. Very unfortunate, but very true. We've already seen an uptick in these attacks with some of the customers that we serve today with our product. And with that, I'm going to hand it over to Dor from ARMIS Labs.
Okay, thank you, Curtis. So hey guys, I'm Dor. I'm a researcher at ARMIS Labs, which is the research part of the company. And to continue Curtis's points, today we're going to talk about why do we even do research and publish vulnerabilities, what's the security disclosure process and how does it look, how do we approach research, and then we're going to look at 2 study cases of vulnerabilities that we published. One affects the medical industry directly, the other affects the medical industry indirectly, and affects not specifically medical devices, just the network of the hospital. We'll go into it later, and we'll see the difference between finding a vulnerability in a medical device and finding a vulnerability in a more standard networking device. So, to go back to the first point, why do we even do research and publish vulnerabilities? So we believe that a good defense requires a detailed knowledge of the offense. So we need to understand how the offense acts, how a bad actor would act, and to try to imitate that and understand where is the next place is going to attack. We do believe that attackers usually target the weakest link in the chain. That Curtis made an excellent point. It is those exact devices. And usually that's the most cost-effective way to be an attacker. Find the weakest link in the chain and then break it. That's why we focus specifically on those devices, which I'm going to go into in a bit. And we also believe that openness benefits defenders more than it benefits attackers. That's a really key point here, because every research we do, every vulnerability that we find, we write a white paper, we publish it, we publish an advisory along with the vendor that is affected, and we make every knowledge of it public. So some would ask, how does it benefit defenders if attackers can see it as well and use it? And we believe that doing something in the light is better than doing it in the shadow, for sure, just because the point that attackers could already had that capability, and us putting it in the light is better than just saying, we hope no one found it, because bad actors has some pretty good researchers as well. And we believe that shedding a light on something will maybe even in extreme cases will benefit attackers in the short term. In the long term, defenders will look at the attack vector and can close or kill a whole class of attacks that will eventually be beneficial to us as defenders. And doing that, you can imagine, is challenging some industry norms. And we believe that if we do it and people are suddenly aware of a big security flaw that they have, they will improve security in the overall part of the system or attack vector, which will benefit even other fields in the same area that we found the problems in. So what's our day-to-day job? Basically, we research attacks that will directly impact our clients. We're a security company, we have clients, and we'll try to understand attacks that will likely would happen to them or how it would happen to them and try to prevent it prematurely. We focus mainly on the unmanageable devices, as Curtis mentioned. Those are the problematic devices in ARMIS perspective, so we focus on that. That means medical devices, OT devices, or IoT devices. And we also research potential threats and anomalies we discover in the wild using the ARMIS platform. Obviously, if we find an attack or something, it's our job to understand exactly what happened and how we can prevent it in the next encounter. We also, when we publish a vulnerability, we try to disclose it and mitigate it correctly and in a timely manner. We'll see it in a bit in the 2 study cases, but for now, I'll just say that disclosing in a time, it's a really, really thin balance that you need to keep, because you want to make it public as quick as you can, but you don't want to make it too quickly, so people want to be able to patch and install and make sure patches are available. And also, you want to make sure that the patches that the vendor makes are actually fixing the problem in a more broad sense than some vendors would like to. And it's a fine balance you need to walk. And also, we believe that if we can find it, a bad actor will find it too, which relates to what I mentioned earlier. When we put a light on it, we believe it's better for everyone. So let's dive deep into the 2 study cases that I'm going to talk about. The first one would be Urgent 11. Basically, it's a class of vulnerabilities that we found that affects an operating system called VxWorks, owned by a company named Wind River. I'm going to go into detail it just in a bit. And CDPON, which affects tons of Cisco products, VoIP phones, networking equipment, that kind of thing. So CDPON affects the medical industry indirectly, and Urgent 11 affects medical devices directly. So before we go into that, just a quick question: why did we even do Urgent 11 or CDPON? Is our approach that I described to you even successful? So it's kind of hard to tell, but I can show you this graph, which is a vulnerability that we published in Android, iPhone, Windows, and Linux in effects Bluetooth stack. And you can see the amount of research being done to Bluetooth prior to our publication and after it. You can see that now Bluetooth is a much more researched area than it used to be. And I'm not saying we did it all by ourselves, but I think we helped to push a wagon with other researchers and to shed a light on this attack surface, which is now much more researched and looked at than before. Okay, so going back to Urgent 11, I mentioned it affects VxWorks. So what is VxWorks? VxWorks is a real-time operating system owned by a company named Wind River and used by more than 2,000 device manufacturers. That's a big number, and I'm not overstating it. VxWorks is probably used by anyone, as you'll see in a minute. It's been around for 32 years, a very old, very reliant operating system, and it runs over 2 billion devices. You could call it the Android of embedded devices, or the Windows of embedded devices, because that's the same number of devices powered by Android or Windows, which is crazy. And unlike Android or Windows, this operating system suffers from the lack of research for a long time. 32 years, only 13 vulnerabilities were found in this operating system before we looked at it, and we added another 11. So that's a big step into looking at this operating system. So where can you find it? You can basically find it in every industry that has device manufacturers. It's been in the healthcare industry quite a lot, in manufacturing, network infrastructure, security, auto, aerospace, everything. It's probably, if you are going to make a device and you need a reliable, embedded, standardized, real-time operating system, VxWorks would be your go-to tool. And there is this story about the Mars rover that NASA launched onto Mars that runs VxWorks as its operating system. So even NASA qualifies VxWorks as the most reliable operating system out there for real-time operations. So it might not come as a shock to you that many big industry players are using this vulnerability. Because you're in the medical field, I guess you spot out Schneider, GE, Philips here, which uses VxWorks to power many of their medical devices, but also Rockwell Automation and all sorts use it to power industrial controllers and Airbus. And you can see a lot of big names here, which means it's really far spread out. So what is Urgent 11? Urgent 11 is our 11 critical zero-day vulnerabilities we found in the TCP/IP stack of VxWorks. What is a TCP/IP stack? Basically, it's the name of the part of the system that does the networking. As Curtis mentioned, every device is connected to a network, and it needs to talk to other devices in the network, and every logic that comes into the device that runs VxWorks, that is the logic of communicating and networking, is coming from the TCP/IP stack inside VxWorks, which is named IPNet in this case. So we found in total 6 remote code execution vulnerabilities, which means that you could run code on the device remotely, obviously unauthenticated. And also we found 5 info leaks, denial of service vulnerabilities, and logical flaws. When I say denial of service vulnerability, usually this means the lower class vulnerability, which is easy to exploit and just denies the service of the device, just shut it down or crash it. But in your case, in the healthcare industry, it might be as worse as running code on it, because shutting down a medical equipment is quite severe. And our vulnerabilities affects VxWorks from the last 13 years and affects hundreds of millions of devices. So let's talk about how the disclosure process worked and how did we manage to go public with this finding. So at first we contacted Wind River, the company that owns VxWorks, and a month went by without getting somewhere. We talked to them, the guy from their PSERT had just left Wind River, and it took us about a month to get an actual response from there. And once we did, we understood there is no way they're going to make into the 90-day responsible disclosure period, which is an industry standard in the security disclosure process, which means you give your vendor 19 days to respond to the security disclosure, and then you go public with it. So they would have an incentive to fix it in a timely manner. But in this case, we understood it's not logical to ask for them to keep inside the 90-day period because they had a hard time managing it. So we gave them an extension. We send them a POC, which is a proof of content, meaning it's a small code or a piece that will let them reproduce the problem in their lab and try to test and see and build fixes on top of it. And once they had patches ready, they sent it us for approval. We approved it, and then we went together to send an advisory to the affected clients and all those people. And then we started suspecting other operating system might be affected. We contacted the DHS. I'm not going to go into that right now, but we're going to talk about it in a bit. And then we went public and published our white paper. So what happened in that dot that you can see right there? So basically, we were contacted by the FDA. We previously contacted the DHS, but apparently government agencies really don't talk to one another, just like on TV. So the FDA contacted us, and they were suspecting other companies and other operating system might be involved. And we started suspecting them as well, because ARMIS has been from the get-go started tracking down at our clients devices that might be affected by this vulnerability. And we found some interesting results that I'm going to let Curtis tell you. And we think that potential vendors might be still out there. We tried our best, and Curtis is going to tell you a story about an interesting one that happened in a client. So Curtis.
Thanks, Dor. Yeah, so this is a really interesting story. So as Dor mentioned, once our research team ultimately discovered or made the full discovery around Urgent 11, these exposures, what we did is we updated our product. We updated our product to help our customers and those assessing our product to be able to identify whether or not they were exposed to these vulnerabilities in their environment, meaning were they running devices that were running Urgent 11 or vulnerable to the various forms of attacks that we had disclosed. One of our customers that was using our product had ultimately identified that in this case, an Alaris device was indeed, or appeared to be vulnerable to this, at least the subset of the VxWorks vulnerabilities and attacks against those vulnerabilities. So this customer reached out to ARMIS, and they contacted their primary sales contact and brought awareness to ARMIS that not only did they see this within the platform, they ultimately believed this to be a false positive because they knew that any of the devices they had in their landscape were not VxWorks devices. But what we were actually looking for was not VxWorks, but rather IPNet, the TCP/IP stack that Dor spoke to. A couple reasons for that. One, because that's really where the vulnerabilities lied, but also because, as was mentioned, the FDA, ARMIS themselves, DHS, all ultimately believed that this might have gone further. Well, when we got this call, it was one of my favorite parts of the story is came in again through sales contact working through for the customer, and the sales contact reached out to Dor's team, our research team, and actually contacted the head of research and brought awareness to the head of research as to what had been found. And as you see, it was this device here within the environment. And the head of research's response was, cool. The reason why he had that response is because the customer just validated what we all believed. Turned out that not only was this specific pump not running VxWorks, it was running IPNet, and it was vulnerable to a subset of the attacks that we had identified in relation to VxWorks. So what this ultimately led to was discovery that this wasn't just impacting VxWorks, but rather was impacting potentially a number of other devices using other operating systems, et cetera, which leads us into a very interesting other dynamic as part of this story. So one of the long-term or long-time security events known as DEF CON in more recent years has held a number of different hacking villages. And this is a great environment where they bring together manufacturers and research teams, just like Dor and his team, to ultimately determine how vulnerable these devices are. So as you see, you can see this capture the flag sign there. Capture the flag in security terms typically means that you're going to try to successfully break into this device. You're usually given a specific goal that you have to accomplish, and you've got these research teams that are going at the goal to ultimately either prove or disprove the security of the device. So it just so happened that the BD-Alaris device that we had discovered as being vulnerable through our software was one of the devices that was on the Biohacking Village floor, along with BD. So BD was kind enough to allow us to test this device, test it live on the floor, and what you can actually see here before the device was unplugged and we were asked to stop for the time being is the zoomed in image is actually a communication error. And that was triggered by the attack that we had tested against this device, ultimately, again, proving that, yeah, the device was vulnerable. A subset of the attacks that could be used against any vulnerable VxWorks device could indeed be used to compromise, affect, take down, etc., the BD-Alaris device, making this event a lot larger. And with that, Doral, I'll hand it back to you.
Okay, so that's a really cool story, but let's try to understand what happened here. Once we did it and we managed to crash the Alaris device on the DEF CON show floor, we started to look into what exactly happened here and how is it possible that the device maker didn't even know that his device is vulnerable. So basically, the IPNet stack was originally developed by Interpic, a Swedish company, in the early 2000s. And about in 2007, they were acquired by Wind River, the same company that owns VxWorks, and they incorporated inside VxWorks as an integral part and as the networking part of VxWorks. So we thought that we were looking at VxWorks code, but we were actually looking at code that was bought from a different company. So apparently Interpic didn't just sit around and waited to be acquired by Wind River. They sold their IP stack to a whole bunch of operating system manufacturers. They sold it to Integrity, to Nucleus, which are really popular operating systems. They sold it to Itron, which you can see in the bottom left there, which the closest thing to a logo is a kernel schematic, which is amazing to me. And INEA OSE, which is also a pretty common operating system, the one that Alaris' device used, and was also funded by the same guy that founded Interpic. So that might not come as a shock to you. So what happened here? Basically, the device manufacturer bought an operating system that inside this operating system supply chain, there were this IPNet stack with the vulnerability. And once they bought it, they made a device and sold it to you. So basically, you have a supply chain inside your supply chain, which is a really big problem to track down and try to understand what happened in terms of the security of it and level of indirection. So is the problem solved now? I wished I could say yes, but the short answer is no, it's not solved. You can Google Interpic company, and the first two images you will find is the thumbnail for our Urgent 11 video and the so-called Alaris pump that used to be considered not affected. But that's obviously not enough, right? Because you want to understand that every vendor, every device manufacturer that we contacted and had in contact would go and understand that it's a problem, but there are too many levels of indirection here in the supply chain. So now I want to talk about the next part of the research, which was trying to understand how we can do it in a more practical manner. Because saying you can find a theoretical problem inside medical equipment is not good enough to go and alert your medical clients, right? You need to show it. And I think there is a really big problem inside the medical industry when they think they're safe because people can't buy medical equipment that easily. It's not just like buying a router and then playing around with it at home. It's expensive and it's not sold as commonly. So that's not true. Basically, you can find almost anything on eBay. I know you can't find an MRI machine, but maybe you can find some part of it, which is the interesting part for you. And so basically, we went on eBay and found this patient monitor that is common in some of our clients, and we wanted to see if it's affected by our vulnerability. So what we did, we bought it. We tried to convince our local FDA that it's okay for a cybersecurity company to buy and import healthcare equipment. And then we opened it up and we spot this little header right down there, down in the left, which basically allows you to connect to the CPU and download software from the memory of the device. So now we have the code that the device actually runs, and we can understand how it works, how to exploit it. And indeed, it was exploitable, and we managed to make a practical exploit. And this is an important step in the research, because you need to show that you can actually do stuff with it, and it's not just, you know, all in the air. So if you could do anything on a patient monitor, what would you do? So we decided to practically scare a nurse to death. I'm joking, it's just, we just did it in a testing environment, but still. And we also have a really common thing we do in our team, and we usually try to run games over it. So we try to run Doom, which is a game from 1995 on this device, and managed it with some success, but the big success was when we tried to run it on this Cisco VoIP phone that you might be familiar with, which is a nice segue to the next vulnerabilities that we're going to talk about. So now that we understood Urgent 11, let's dive into the second vulnerability, which affects the medical industry in a different way, in an indirect way. So CDPON is basically 5 critical 0-day vulnerability that we found inside some protocol that Cisco uses. It affects tons of Cisco devices, tens of millions of devices. And just so you get a reference, if you haven't heard the name Cisco yet, which I'll bet you have, 95% of the Fortune 500 companies uses Cisco solutions inside their networks. And this vulnerability affects a whole ton of them. It affects switches, VoIP phones, you name it, routers. I'm betting most of you have seen this equipment before. And this specific VoIP phone that we had fun with is apparently very fond of by US presidents. So that's an interesting concern. And also the main thing that CDPON can do, which is the scariest thing, I think, is that it can break network segmentation. And if you're unfamiliar with the concept, it means that basically you have a networking equipment, in this case, the core switch, and you can divide the network into segments, into areas, which only stuff that should talk to one another should be in. So if you have your Amazon Alexa, it could be in another segment than your MRI machine. So if for some reason the Amazon Alexa is compromised, it can talk to the MRI machine. And we've seen this used as a security practice, which is actually not that good, because in this case of CDPON, if you have a vulnerability that can affect the actual network infrastructure, you can break it quite easily and access whatever you want inside the network. So CDPON was a clear example that segmentation, while being a good idea, isn't perfect and isn't a security solution, it's a networking solution. So with that in mind, we started to disclose CDPON. So first of all, to contact Cisco is really, really, really easy. Cisco is a very security-aware company. They do disclosures all the time. They handle this sort of thing really all the time. And they have a very experienced PSERT, which is the guys who are responsible for the security disclosure. In Wind River example in Urgent 11, it took us about a month to contact them. Here they have a 24/7 hotline that you can call and report a vulnerability in the middle of the night, which is just amazing to me, and light years from what we experienced before. And the timeline was pretty straightforward. We started contacting them. We had patches to approve. We approved them. We found additional vulnerabilities during the disclosure process. We extended the 19 days again. And we went public when Cisco issued CVEs, which is the identifier of the vulnerabilities that Cisco recognizes and how severe are they. Basically, really, really straightforward. So what can we learn from those experiences? First of all, Urgent 11, contacting the relevant parties was really, really hard. And even getting in touch with the vendors was really, really hard. In comparison to CDPON, which was a breeze, just calling Cisco and talking to them. They are very professional and they've seen this before a lot. As I mentioned, Wind River had only 13 vulnerabilities alive for Wind River VxWorks before we started researching, meaning that the team that handles it probably didn't handle a lot before, in exception to Cisco, which handles it on a daily basis. In Urgent 11, we understood that because it's taking time to deliver our message and making sure everything is okay, we have to extend the responsible disclosure period We did no such thing in CDPON. It was really straightforward. They wouldn't manage to keep up on time. And working with the vendor on a patch in the case of Urgent 11 is really just the tip of the iceberg, because making a patch doesn't mean that the device manufacturers would actually apply them, and all of those levels of indirection would have to supply, meaning the device manufacturer would have, the operating system would have to fix the IPNet part, the device maker would have to update the operating system and update the device as well. So it's a really long chain that you have to make sure works. And we tried as hard as we could, and I still think we probably didn't cover everything 100%, but we did talk to the government and try to do as much as we can to solve that problem. In comparison, Cisco just patched the problem, that's it, it's dead. You have an update right there. You don't need to talk to other makers, other vendors, stuff like that. This, as Curtis mentions, that's the same case in Microsoft or in Apple that has like regular patches deployed, and people, IT people inside companies knowing how to handle those patches. I bet some of you didn't patch your MRI machine ever, so you might have to, or your patient monitor, it doesn't happen that often, which is a problem. And making sure our patches are deployed is really, really next to impossible, as I mentioned, because ARMIS isn't installed in every hospital in the world. We can monitor all the patches for all the products in the world. So just talking and convincing other parties to participate in this conversation is quite a challenge. When you look at Cisco, some patches are even pushed automatically. Some people doesn't even know their equipment are being updated, or semi-automatically maybe a pop-up comes up and says, you have a security problem, please click here to update your firmware. You click and that's it. And because even the vendors are not aware of the supply chain they are affected by, how can you be, and how can you make sure you're not affected by this without using a security solution like ARMIS? So that's a really, really big problem, and that's the problem we aim to solve, one of them. And also, when Cisco writes the code, it's maintaining the code, that's it. There's no supply chain there. They can issue a fix really quickly, and you don't have to go into other levels. So just as a story, that's how like the modern world works when fixing a vulnerability. I'm joking, that's not really how everything works, but that's a really good example of how it should work. Here you can see a picture of GitHub, which is a code sharing website, and you can see that in the middle of their project, there is a bot here who discovered a vulnerability in a dependency. It updated the dependency, and it asked another bot to merge it into the main code. The bot agreed to merge it, tested it, and celebrated the merge, while you can see the human there was quite terrified that everything happened automatically. So that's it. Now Curtis is going to take you to how do we look at it and how do we solve it. So thank you.
Thank you, Dor. So obviously, we don't want to speak only of the problem itself. We do want to speak to the solution. Now, before I dive into that, too, one thing I did want to add to what Dor just spoke to is one of the things that I'll often talk to customers and potential clients about is we all remember the NSA leaks that ultimately led to WannaCry and NotPetya. But one of the really interesting pieces of information that came out of the NSA leaks were the fact that nation states, including our own, were actively targeting IoT devices around the world, refrigerators, various forms of appliances like washing machines, televisions, etc. And I think some of the insights that came out of that are particularly interesting and relate back exactly to what Dor stated, because the reality is this: nation states and bad actors have their own research teams. They're identifying a lot of the same exposures, and they're exploiting them unbeknownst to anyone. The research that Dor and team do allows us to ultimately get in front of these nation states and bad actors and bring the tools back to everyone's hands and shine light into the darkness. And so as you look at that, before the NSA leaks, before the likes of companies like ARMIS doing the things that we're doing and researching into these devices that were never researched before, wasn't a lot of attention being given to these devices on the legitimate side, but there was a lot of attention being given to these devices on the illegitimate side, and that continues to be the case. So with that, how do we help our customers actually solve these problems, and where do you start? So most security programs, and actually there are specific controls written around this as to how to form a security program from scratch, truly begin with understanding what you have. You can't build an effective security risk management strategy before you understand the devices in your environment, the software in your environment, how those things are actually used in support of the business, which devices, software, assets in general are more important to the business than others, how should they be monitored, et cetera, et cetera, et cetera. We truly help our clients identify or solve this problem by helping customers identify every single device in an environment that communicates over a network, any form of network, wireless, wired, over-the-air technologies like Bluetooth, as Dor mentioned. We truly help customers identify what's in their landscape, build a strategy around it, and then start rolling into the next point, which is, why do I care? So not only will we help our customers identify that those devices exist, help understand what's normal within a landscape, how are these MRI devices normally being used, what are they normally communicating with versus abnormal, malicious, or more malicious-like communications. We actually provide you with insights into risks, vulnerabilities, like we spoke about today. So our product will provide our customers with insights into devices that are vulnerable from an IP net perspective, that are vulnerable from a CPON perspective. We do provide those insights. We will also provide threat and risk assessments around the various devices that exist in the environment based upon all other forms of vulnerabilities, and even including some of the notifications and advisories that are issued by governments like our own around Hikvision cameras and such like that. So we provide visibility into how an enterprise is exposed, and then we also enable customers to manage those risks. So that ultimately means a lot of different things. So for example, when it's a less critical device, like let's say, for example, a smart TV in an environment, we give our customers the ability to isolate that smart TV, prevent it from communicating with anything else, either automatically or manually. And then in terms of being able to respond to, say, an attack against an MRI machine, we're providing all of the insights in such a manner back to the cyber response teams that they can respond or understand and respond to these incidents like they have any other incident happening on any other form of device. The insights, the context that we're sharing in such a way, again, that it's similar to what they've always looked at. So you don't need specialists that focus just on IoT or OT or unmanaged devices to be able to understand and respond to those risks and issues. So one of the things that I did want to touch on as we relate to that is, we often are questioned, what are we actually finding in these environments? So first off, as you saw through some of the other data points in this presentation, these are not hypothetical situations. These devices are being attacked by the likes of nation states, criminal actors, et cetera. And again, 25% of the attacks in 2020 will consist of attacks through these devices. So these are examples of what we have seen through our product and the implementation of our product in customer environments. So the first one on the list, as you see, is MRI machine and others. Others being that there was ultimately a worm or malware infection that spread through this environment. We're communicating with command and control centers in Russia, meaning these devices have been compromised, were added to what is known as a botnet, and we're waiting for commands to do other things. Those other things could have been take down this hospital environment, could have been use the assets in the hospital environment to attack other environments, rendering them unusable to actually provide patient care and deliver services to patients, et cetera. Pretty significant exposure in that case. We've seen many WannaCry infected medical devices spreading across a flat open network. WannaCry devices, or many of these devices that have been affected by WannaCry, are actually Windows devices. So as we spoke to in many times, or many cases in this session, a lot of these devices are hard to patch. You patch them, they need to be recertified by the FDA. The patch may be problematic for a number of different reasons. You may not be able to apply it effectively. And these devices were built to be in service and to work for decades in some cases. So in many cases, we are seeing these highly vulnerable devices running very old operating systems that are no longer receiving patches, that have a wide understanding of the wild in terms of how attackers can compromise these devices, et cetera. And that's ultimately what led to this event at one of our customer sites. We've seen an infusion pump compromised by malware while it was connected to a patient. In this case, the malware was not intended to affect like the level of service being provided, but like much other malware and ransomware and such like that, could very much have affected this device while connected to the patient and simply just cut off service. We see medical crash cards being used to access Facebook and other sites, and then since have been used to access phishing sites and have been compromised through some of those phishing sites or have compromised information as a result. And then last but not least, X-ray machines and others sending patient information and diagnosis details unencrypted over the internet. In this case, it wasn't an attack, but what we also help our customers identify is not just that attacks are happening in the environment, again, help understand the risks and exposures that exist in your environment because of the devices that are in the environment or how those devices have been configured. In this case, the X-ray machine had the ability to send the information in an encrypted manner. It just wasn't configured as such. So let's dive a little deeper into our mission. And I wanted to talk about this slide just for a moment to really touch on what Dor spoke to, both looking at vulnerabilities that directly impact medical devices and those that impact other devices that exist in a medical environment. The printer example is a really good example because it exists almost everywhere. We've seen this in highly controlled manufacturing environments, all the way to healthcare environments, almost everywhere. Most of our customers have experienced a finding of at least one, if not a number of printers in their environment that have been set up as an open hotspot. A lot of them are by default, meaning that they have their own wireless ID that you can connect to as a separate wireless network, but it's because this printer is also connected to the corporate or enterprise network, you can then connect from that printer into other things, execute attacks, such like that. We see, unfortunately, many cases where this is the case. Folks can also break into these printers and access the memory on these printers, which stores data around documents that have been printed, scanned, etc. So this is an example of an IT device that would exist in a healthcare environment. And the reason why looking at the problem and the picture holistically is incredibly important. An attack can start at one of these devices, spread into the healthcare environment, and in many cases what we see with the likes of WannaCry attacks is they'll start on a more traditional device and start affecting the rest of the landscape, therefore affecting the ability to deliver care and such like that. So how does ARMIS work? I'm not going to go into the deep technical aspects of this, but just touch on a couple key points. Our solution is a agentless solution, meaning that, like we spoke to earlier, you can install agents or software on a lot of these devices, but you need to be able to understand them. What are they? What are they supposed to be doing? What are they actually doing now, etc. So how do we do that? We do that by integrating with your existing networks, wired, wireless. We, through either a virtual or physical appliance, will connect into that network and passively, meaning we're not touching those devices at all, use that network information to understand those devices. What are they? Where are they? Who's potentially using them? What are they connecting to? And then most importantly, we'll start building a baseline of what's normal and start exposing abnormal behaviors, potentially malicious behaviors, etc. So we truly take advantage of investments that you've already made into your infrastructure. We take the information that infrastructure is already gathering and building, and we take that and we learn from it. We learn about your environment, and then we help you manage your environment by connecting back into some of those devices and allowing you to even take effect or take action on some of those devices should they be potentially compromised or show signs thereof. So with that, that is the end of our planned remarks. So we're happy to open up to any questions that there might be out there.
Awesome. Thank you guys so much. Unfortunately, we do only have 2 minutes left for questions. And I see we do have quite a number of questions coming in. So please keep entering in your questions. I've documented all these questions. I'll work with both Dor and Curtis to get the answers to these and send them out as part of the follow-up. Since we only have 2 minutes left, I don't want to ask any questions because I have a feeling most of these questions are going to take some time. Just to give a couple last remarks, we will be sharing the presentation material, including question and answers following this presentation. It'll probably be at least a week. We'll be entering them onto the ACCE website. If you're an ACCE member, you'll be able to access it. Just wanted to thank Dor and Curtis again and ARMIS for presenting with ACCE Education Committee. For those of you who have signed up for the education sessions, please note that some of those dates have changed due to COVID-19 activities. All of our presenters for May and June, unfortunately, are in the Northeast, which is getting hit pretty hard with COVID. So we've rescheduled for July and August. If you have any questions, please feel free to reach out to ACCE education chairs, and myself or our co-chair Eric Ehring will be answering all of those. Otherwise, thank you guys so much and have a great day.
Thank you for having us. Thanks.